Spark is a parallel execution framework which enables us to perform operations on big data sets in a highly parallel fashion. You might be familiar with Hadoop. Now, this is still a very popular parallel execution framework which uses the MapReduce framework to crunch big data sets. And it was a revolutionary technology, but it suffers from two problems. Firstly, it's a very rigid model. You must do a map and then a reduce process, which is powerful, but maybe not suitable for all requirements. Well, definitely not suited for all requirements. Its second weakness is that if you have complex requirements, then you need to chain together MapReduce jobs. And due to the way that Hadoop MapReduce is designed, after one MapReduce is finished, the results have to be written to disk and then reloaded into the next map task. So there's quite a hit on performance there. And that's why at the time of recording on the Apache Spark homepage, the very first thing they say is they're comparing themselves to Hadoop, and they reckon that a Spark program can run up to 100 times faster than Hadoop MapReduce, assuming that you can do the job in memory. Or if your data's too big to fit in memory and you have to spill to disk, then you're still going to see a 10 times faster performance. So clearly, Spark kind of defines itself in comparison with Hadoop MapReduce. So speed's one thing, but how else is Spark different to Hadoop? Well, Spark is going to allow us to build much richer jobs, and we can use combinations of not just maps and reducers, but also operations such as sorts and filters and joins. And well, actually, as they describe here, there's over 80 high-level operators, meaning that we have a much richer set of tools than just MapReduce. And the really mind-blowingly clever thing about Spark is that rather than just stupidly doing one task after another, it actually builds something called an execution plan. And this is where it builds a graph representing the work that we want to do. And only when we're ready to get the data results that we want will Spark actually run that execution plan. And this means it can perform really clever optimizations, such as it can spot that two parts of your process are not dependent on each other. Therefore, Spark can decide to run those two parts in parallel. We don't have to think about that in the code. That will be spotted by the execution engine at runtime. Before we start coding, I think it's worth having a very high-level look at the overall architecture of Spark. When you're working with Spark, you're going to be writing really regular Java programs, which you can run absolutely no problem on your local computer. And it will run in a kind of a standalone mode. Here's an example. You don't need to understand any of what you see here. You will be building this code later on in the course. But I kind of want to draw your attention to just the general feeling of what's going on here is I'm doing various operations on a set of data, pretty much in the same way that I would be operating on a set of collections in Java. I can run this program just as I would run a normal standalone Java program. There's no cluster here, and the program ran. And this standalone mode, by the way, is actually really, really useful because when you run Spark on a single computer, you get the full benefits of multi-threading. And in fact, this Spark program will have been distributed across all of the available cores on my development computer. So I think this is often forgotten. Even if you're not working with massive big data, obviously big data is where the fashion is at the moment, but there's a lot of people benefiting from using Spark on relatively small data sets that they can efficiently program in a multi-threaded way on a single computer. Now, you could have done this using Java's threading, but if you've done any work with threading, you will know how dangerous and difficult it is. But with using Spark, you can get the full benefits of multi-core parallel processing without having to think too deeply about threading.